We are living on a huge ball that moves through space very fast. Its orbital speed around the Sun is approximately 100,000 km per hour, and the speed with which it is spinning at the equator is around 460 meters per second. But still, we're living normally our daily lives like nothing really happens. Why is that? What doesn't allow us from escaping Earth's atmosphere that easily? And why are we all flying off to space? The first person to answer those questions was Isaac Newton. In 1678, Isaac published a number of equations that helped describing gravity. One of them described gravity as a universal force acting on every object in the universe that has a mass. The smaller the mass of the objects and the bigger the distance between them, the weaker the force acting towards them. That means that if we went to another planet, we would feel heavier or even lighter depending on the mass of the planet. So let's go and do that.
See, on the Earth I weigh about 50 kilograms, and on the Moon I weigh about 8 kilograms, and if I go to Mars I weigh about 20 kilograms. And now I will go to Saturn, where I weigh about 45 kilograms. As you can see, although Saturn is very big, its mass is very small because it's made of mostly gas, so I weigh a bit less than Earth, where I weigh about 50 kilograms.
Unfortunately, Newton's law of universal gravitation had some issues. It couldn't, for example, explain the orbit of Mercury around the Sun or the bending of light near massive objects. Thus, in 1915, Einstein published the well-known general theory of relativity that describes the phenomenon of gravity better and more accurate than ever. He said that space and time is one thing, aka spacetime, and that mass is bended, so objects follow the curvature of spacetime and orbit around other objects. The theory of relativity predicts a lot of things as well, like black holes. Their density and mass is so big that they technically fold spacetime and shadow everything nearby.
So I've got here an instrument that we can show the way that black holes attract objects. So let's say this is a planet. Let's place it and let me give it a push. And see how it goes. As you can see, the closer it gets to a black hole, the faster it goes.
Well, that's all that we know about gravity so far. But scientists keep trying to find a new theory that will describe gravity with quantum mechanics. But there's a lot of progress that needs to be done, so what are you waiting for? Maybe you are the one to unlock this big